Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023, Paper 4, Variant 2 for Cambridge IGCSE Physics. We will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these exam questions. Let's study together, let's improve together. In today's lesson, we are talking about May June 2023 Paper 4 Variant 2. Total time for this exam is 1 hour and 15 minutes and you need to answer all questions on this paper. And total mark for this paper is 80. Question 1 part A says figure 1.1 shows a helicopter which is stationary at a height of 1500 meters above the ground. For part A1 we need to state two conditions necessary for the helicopter to remain in equilibrium. So simply we need to understand what is meant by equilibrium. Body is in equilibrium if resultant force on body is equal to 0. So first condition, simply you can say resultant force in any direction. Proper way to say is resultant force in any direction is equal to 0. And the second condition is resultant moment about any point is equal to 0. Resultant moment about any point is equal to 0. So these 2 points you have to write down. So condition 1, condition 2. If you want to write down here, simply you can say resultant force is equal to 0 at IGCSE level. If you simply write down resultant force is 0, 1 point, you can say resultant moment is 0. You will get 2 points. Means you will get 2 marks. Resultant moment is 0. But the proper way to state this one is resultant force in any direction is equal to 0 and resultant moment about any point is equal to 0. So if you write down these 2 points, you will get 2 marks. The first mark is B mark, means this has to be in your answer, and this is also B mark. This has to be in your answer. Second part says the mass of the helicopter is 3200 kgs. Calculate the change in the gravitational potential energy of the helicopter as it rises from ground to 1500 meters. So ground we can take our reference point, means h is equal to 0 here. So in this case the change in height, so simply then we can say change in height in this case is equal to delta h. We need to calculate change in GPE, so we can write down delta GPE. This will be equal to mg delta h, change in gravitational potential energy. So this is the change in gravitational potential energy. Mass of helicopter is given to us, that is equal to 3200, and value of g we can use 9.8, and the change in height we have, that is equal to 1500 meters. Now if we simply multiply, we will get our final answer is 4.7 times 10 to 7 joules, or we can say this is equal to 47 megajoules. So we can say 47 megajoules, because 4.7 times you can say 10 to 1 times you can say 10 to 6. So 4.7 multiplied by 10, we will get this is 47, and 10 to 6, this is mega. So it means this is 47 megajoules. And this question has 2 marks. You will get 1 mark if you have written this equation. You will get 1 C mark. If you got the right answer, you will get 2 marks. Part B says figure 1.2 shows a vertical speed time graph. Vertical speed time graph simply means that we are talking about vertical motion only. So we are talking about vertical motion only. For a parachutist who jumps from a stationary hot air balloon, the parachutist jumps from the balloon at time t is equal to 0 and reaches the ground at B. The point A indicates when the parachute opens. On figure 1.2, label a point on the graph where acceleration is 0 with 1, negative with 2, decreasing with 3. So first thing you need to understand, we have speed time graph. So what is the gradient of this one? So this is the key concept you need. Gradient of VT graph. So what is gradient of VT? V against T graph. Gradient is equal to acceleration. So this is the key concept you need to answer this question. Now if you look at the initial part here, first of all let's try to find out 0 with 1. 0 means that gradient is 0 because gradient is equal to acceleration. Acceleration will be 0 when gradient is 0, and gradient is 0 at this point. You can mark 1 here, you can also mark 1 here because gradient is 0 here, so we can mark here. You can also mark here, so it is also correct. Anywhere you can mark on these 2 points. Negative with 2, negative where acceleration is negative means where gradient is negative. If you look at this part, gradient is negative, so we can mark 2 here. So this is negative acceleration. Decreasing, so you can say gradient is decreasing, so it means acceleration is decreasing. So we can mark anywhere here. So this is the third point. So this is third point. You can mark this is as 1, and this one you can mark as 2. So this is how you can mark. Second part says explain in terms of forces the changes in motion which occur from when the parachutist leaves the hot air balloon until point A. Until point A means until this point. And parachutist opens parachute at this point. Parachute at this point. So we have to talk before opening the parachute. So let me mark here open parachute here. Question is asking us to explain the motion before opening the parachute. Open parachute, so we can write on here. So important point. So open parachute at this point. So we have to talk before this point. We can also draw the line here. We have to explain until this point. Until this point. So simply let me draw this line here until this point. So first of all, if you look at this point, when this person jumps out of plane, we can write down here person jumps out of the plane. So you can simply imagine this is the person. So when this person jumps out of the plane, initially the force acting on this person is mg only. So is mg only. As the resultant force on the person is weight only, there will be no air resistance initially because the speed is 0. So acceleration of this parachute is initially this is downwards, and this acceleration will be equal to g. So we can say will be equal to g because resultant force is mg. When this person start falling downwards, air resistance on this person will start increasing because the speed of the person is increasing. So air resistance will start increasing, but weight of the person will not change. So now we can write on here. Let me write on first of all here. Here we have F net, that is equal to mg. So we have ma, that is equal to mg. So from here we can say a is equal to g. So this one is the initial acceleration as we mentioned here. Now in this case here we have F air, so this is air resistance. So how about resultant force now? So we can say this is case 1 and this is the second. So in this case F net we can write down here F net, this one has to be equal to mg minus F air, and I hope now you will see that this F net is lower than mg because this term is subtracted. So due to this term F net is lower. If F net is lower, how about the acceleration? So F net is equal to ma. So if F net go down, mass will not change, so a also will go down. So now we can go to the third stage. Third stage, when these two forces are equal, so I will be using red color. So at this stage when mg is balanced by F air, mean these two forces are equal, so F air. So we can write down the third case here now. For the third case we can write down F net, this is equal to mg minus F air. But F air in this case, so let me write down here F air, this is equal to mg. So we can write on here this is mg, F air is equal to mg, so it means F net is equal to 0 because this one cancel. So what does it mean? It means acceleration is also equal to 0 at this stage. So we can say acceleration also equal to 0. So it has reached the terminal velocity, mean after you can see this gradient is 0, it means it has reached terminal velocity. So it has reached terminal velocity. Now let me explain you a little bit more about this. So if we start from here, you can see Fnet. If we compare this Fnet with this Fnet, you see Fnet is decreasing. It keep on decreasing. Finally Fnet becomes equal to 0. So if Fnet is decreasing, it means acceleration also keep on decreasing, and finally acceleration is equal to 0 and body reaches terminal velocity. So these points you need to understand, and these points you have to write down in your answer. Now let me show you the answer, how you can write down your final answer. In your final answer, you have to mention these points. You can say, first of all, initially there is acceleration due to weight only. So we have seen resultant force initially is equal to mg, so A is equal to g. Then A resistance increases, as we have discussed here. A resistance increases as speed increases. As A resistance increases, resultant force decreases. We have discussed this point here. Finally, when A resistance is equal to weight, mean A resistance is equal to weight, speed becomes constant, or it has reached terminal speed. So speed becomes constant, mean it has reached terminal speed. And this question has 4 marks. If you have written these 4 points, you will get 4 marks. Question 2 says a student catches a cricket ball. The speed of the ball immediately before it is caught is 18 meters per second. The mass of the cricket ball is 160 grams. Calculate the kinetic energy stored in the cricket ball immediately before it is caught. For this question, simply we need to calculate kinetic energy. So first of all, we need to understand kinetic energy is equal to 1/2 mv square. For this question, we have mass of the ball, that is 160 grams. So we have to convert this one into kilograms. So we can write on here, we have 1/2 and mass is 160 grams. So we need to convert this one into kilograms. So we have to multiply with 10 to minus 3. So we can convert this one into kgs. And the speed is given in meters per second, so this is 18 square. Now if we simplify this one, our final answer will be 26 joules. So this is how you need to answer. This question has 3 marks. The first C mark you will get if you have written this formula, and the second C mark you will get if you have plugged in these values, and the last mark is the answer mark. If you got right answer, you will get 3 mark. Part B says it takes 0.12 seconds to catch the ball and bring it to rest. Calculate the average force exerted on the ball. It is given to us that initially ball has speed u, that is equal to 18 meters per second, and finally its ball comes to rest, meaning the final velocity is equal to 0, and the time taken between initial velocity and the final velocity is given to us. The time taken delta t, this is equal to 0.12 seconds. We need to calculate average force exerted on this ball. F is equal to delta P over delta T, means the net average force. So delta P is equal to m times delta V divided by delta T. Mass is given to us, that is equal to 0.160, and the change in velocity we have. So we can write down 0 minus 18 divided by delta T, that is 0.12. So in this case, we will get answer that is equal to 24 newtons. This negative sign simply telling us that force is applied in opposite direction of motion of the ball. And question is simply asking us the force, magnitude of the force. So you can say 24 newtons. So this is how you can approach this type of problems. For part C, it is given to us as the student catches the ball, she moves her hands backwards. I mean, catch the ball like this and move the hands like this. Explain the effect of this action on the student hands. Why student when catch the ball move the hands back? So what is effect of this action on hands of the students? So for this purpose, we need to understand delta P, this is equal to F times delta T. Change in momentum is the same. Change in momentum is the same because ball has initial velocity here and final velocity 0 and mass is constant. So this quantity delta P is constant. So if student increase the time time taken mean increase this time taken. Let me use the red color. If we increase this time taken, we can reduce the force. So that's the point you need to understand. So simply we can say force decreases on the hands of the student. So simply you can say force decreases as time increases, or you can say longer time. So if you write on this one, you will get 1 mark. This question has only 1 B mark. That's all for today's lesson. I hope this lesson was helpful and you have improved your understanding of mechanics. If these videos are helpful, please like and subscribe because your encouragement is very important. And if you need more help and you want to support the work I'm doing on YouTube, please join Patreon. On Patreon, you will be able to contact with me directly, and also you will be able to ask me more questions on Patreon. And the link for Patreon is in the description of this video. And the solution of remaining questions from this paper I'll be uploading as soon as possible. See you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023 paper 4 variant 2. In today's lesson, we will talk about mechanics, we will discuss thermal physics, we will also talk about waves. As always we will do these questions in detail so you can improve your conceptual understanding of mechanics, conceptual understanding of thermal physics, and also conceptual understanding of waves. And also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 3 part A says figure 3.1 shows a person moving across an ice covered pond to reach a ball on the ice. Explain why this way of moving across the ice is safer than walking. Use your understanding of pressure in your answer. This question is pretty straightforward. This is about pressure. In order to answer this question, first thing we need to understand, if the person is lying on the ice and if the person is walking on the ice, weight of the person is the same. Means the total force exerted by the person on ice is the same. So we can write down the first point. We can say weight of the person is the same. It doesn't matter person is lying on the ice or person is walking on the ice. So it means that the force on the ice is the same. So weight is the same, so force on the ice is the same. Now we need to understand when ice will not crack, means when ice is less likely to be cracked. Ice will be less likely to be cracked if value of P is lower. Crack. So if P is lower, if P is greater, it will crack. So if P greater, ice is more likely to be cracked. So if we can lower P, we can reduce the risk of cracking ice. So how we can reduce P? P is equal to F over A. In this case, F is equal to weight of the person divided by area in contact of person with the ice. If we want to reduce P, weight is the same. Weight of the person will not change when the person is standing, when the person is lying on the ice, but we can increase area. If we increase this contact area, we can reduce P. So these are the points you need to understand. To answer this question is a typical type of question about pressure. So let me show you the answer, how you can write down a proper answer. In order to write down answer for this question, you have to mention these points. First point, you can say force is same, so pressure is lower. So as we mentioned here, force is same, area is larger, so the pressure is lower. Area is larger, so you can mention this point, weight of person is spread over much greater area. So if area is greater, force is the same, P will be lower. So ice is less likely to crack. So these points you need to mention in your answer. So let me explain you one more point. Hold your pen between your index finger and your thumb like this. You will feel more pain on index finger because index finger, you can see this area is smaller. So the pain we feel feel, that is not only due to the force, that is due to the pressure. I used to tell students that pressure causes pain. So if higher pressure, it means you will feel more pain. If low pressure, you will feel less pain. Part B says figure 3.2 shows a side view of the pond with a layer of ice floating on the water. The surface area of the pond is 5.0 meters square and the mass of the ice is 690 kgs. The density of water is 1000 kgs per cubic meter and point X is 0.45 meters below the ice. Calculate the pressure at point X due to the ice and water. So we need to find out value of P at this point. So first of all, we can say this P is Px. So Px in this case, so simply we can write down here, Px will be equal to P due to water plus P due to ice. So this is first of all we can write down. Now we need to understand how we can calculate P due to water. So we have height of the water, so this is column of water. So P due to water will be rho g delta H. And how about P due to ice? So we have ice spread over this area. So ice is spread over this area. So if you need to find the pressure due to ice, this one has to be equal to F divided by A. Now simply we need to plug in values. We have density of water, that is equal to 1000. We have value of G, that is equal to 9.8, and the height we have, that is 0.45. So simply we can write on here 0.45 plus force over area. Force in this case is equal to weight of the ice. Mass of the ice we have, so we can write down this is mass of the ice 690. We need weight, means the force exerted on this surface, that is equal to weight of the ice. So we have to multiply by G. So this is 9.8 divided by contact area, that is 5.0 meters square. So we have 5.0. Now we just need to simplify. So if we solve here, we will get 4410 plus for ice we will get 1352.4. And if we add these two together, our final answer will be 5.8 times 10 to 3 Pascal. So this is our final answer, and this is how you can approach this problem. A beautiful question about pressure. So we have ice, so we have to consider the total weight of the ice over total area. Let's imagine that if we have only weight of this part of the ice, this is given to us, and area in contact is also given. So you have to use the weight of this part of the ice divided by contact area. In this case we have weight of the total ice, so we have to divide by total area. So this is important point, maybe you will need next time. Question 4 part A says the temperature of a fixed mass of gas at constant volume is decreased. State and explain in terms of particles how pressure of the gas changes. So first of all, for this question it is given to us that delta V is equal to 0, means volume remains constant, and it is also given to us that temperature of the gas decreases. So if temperature of the gas decreases, it means that kinetic energy of the particles decreases. So if kinetic energy of the particles decreases, it means that average speed of particles also decreases. If average speed of the particles decreases, it means that lower rate of collision. So it means lower rate of collision is very important point. Most of the time students, they don't understand what exactly it is meant by lower rate of collision. Let me explain you this one with one simple example. Imagine that we have this container and one particle is at the center. This particle will move this side, it will collide this wall, then it will go back and collide the second wall. But now if the speed of this particle has been decreased, this particle will take longer time to hit one wall than to hit the second wall. So it means that at any given instant of time, less number of particles, or we can say fewer number of particles, they will be colliding with the wall. So it means lower rate of collision. And also as speed has decreased, it also tells us that smaller force by each particle. So we can say smaller force by each particle on the wall. So we can say by each particle smaller force, or you can say average smaller force by particle, each particle. So these are the points we need to understand. I hope this point is clear to you. Now let me show you the answer, how you can write down a nice answer for this question. In order to answer this question, first thing you can say, in this case pressure decreases. So P question was asking you, so P is equal to F over A. Area of the wall remains constant. Just imagine whole wall. So area of whole wall remains constant. If the force decrease, it means pressure will decrease. So these points we need to mention. We can say pressure decreases, particles have lower velocity. As we have mentioned, particle speed is lower rate of collision, and particles collide with smaller force. And so if you write on these points, you will get 3 marks. And this is kind of repeated question. Your concept about this point has to be clear. Means why pressure decreases if temperature decreases and volume is kept constant. For the second part, part B1, we need to state value of absolute zero in degrees Celsius. At IGCSE level, you can simply say 273 degrees Celsius. But when you will go to AS level, we will state this one more precisely. We will say this is minus 273.15 degrees Celsius. But at IGCSE level, simply if you write on minus 273, you will get mark for this one. For the second part, we need to explain what is meant by the term absolute zero. Refer to particles in your answer. Absolute zero is the lowest possible temperature, and at that temperature, particles have the least kinetic energy. So this is what we have to mention in your answer. So we can simply say for this one, lowest possible temperature at which particles have least kinetic energy. So you have to mention lowest possible temperature, and you also have to say particles have least kinetic energy, because you have to explain this one based on particles. Refer to particles in your answer. So you have to follow instructions given in the question. Part C says cylinder 1 contains 350 cubic centimeters of gas at pressure of 9.0 times 10 to 4 pascals. The gas is transferred to cylinder 2 and pressure increases to 1.6 times 10 to 5 pascals. Temperature remains constant. So for this question, simply we have to use Boyle's law. So we can say P1 V1 has to be equal to P2 V2, because in this case temperature remains constant. You can also derive this one from here. PV is equal to nRT. As temperature is constant, N is constant, R is constant, so it simply means that PV is equal to constant. So we can say P1 V1 is equal to P2 V2. In this case, we need to calculate volume of cylinder 2, so we need to calculate value of V2. V2 will be equal to P1 V1 divided by P2. Value of P1 we have, that is equal to 9.0 times 10 to 4 pascals. So this is in pascals. And we have volume, that is 350 cubic centimeters. We have to divide by P2, that is 1.6 times 10 to 5 pascals. So this is 10 to 5 pascals. Now simply if you look at the units, we can cancel this unit with this one. So we left with cubic centimeters. So if we solve this now, our final answer will be 200 cubic centimeters. So this is our final answer. And this is how you can approach this type of problems. In this case, you no need to convert units into meters. Question 5, part A says figure 5.1 shows an electric heater used to heat a room. The dimensions of the room are given to us and density of air is also given. We need to show that mass of air in the room is 79 kgs. So we need to calculate mass, and mass is equal to density times the volume. Density of air is given, that is equal to 1.2 kgs per cubic meter, and also we have volume, that is 4.5 times 6.1 times 2.4, and this is in cubic meters. Now simply cubic meter we can cancel with cubic meters, so we left with kgs. So if we multiply this one, we will get 79 kgs up to SF. So this is how we need to answer. This question has 2 marks. First mark is the B mark. If you have written this formula, you will get 1 B mark. Mean it you have to write down this formula. It's very important one, not just simply plug in numbers. Then the second mark is here, this B mark. Mean you also have to show this in your steps. Second part says the power of the heater is 1100 watts. The specific heat capacity of air is 1000 joules per kg per degree Celsius. We need to calculate the time taken to increase the temperature of the air in the room from 16 degrees Celsius to 20 degrees Celsius. This is a typical type of question, so we can simply start with Q. Q is equal to MC delta T. Q is the thermal energy supplied. But in the question, power is given to us, so we can divide both sides by delta T. So we can also divide this side by delta T. So Q over delta T means thermal energy, rate of thermal energy transfer. This is equal to power. So we can write down here, this is MC delta T divided by delta T. For this question, we need to calculate time taken, means we need to calculate delta T. So we can rearrange this, we can write on MC delta T divided by power. Now simply we need to plug in values. Mass we have already calculated in the last part, that was 79 kgs. Value of C is given to us, that is 1000. Delta T, rise in temperature. So the change in temperature we have, this is 20 minus 16, so we have 4.0 degrees Celsius, and divided by power, that is 1100 watts. Now if we simplify this one, we will get our final answer, that is 290 seconds. So this is how we can approach this question. So final answer is 290 seconds. A beautiful way you need to understand how to answer this type of problems. Third part says, suggest one reason why the time calculated in A2 is the minimum time needed to increase the temperature of the air in the room from 16 degrees Celsius to 20 degrees Celsius. Minimum time, because in this case we haven't considered thermal energy loss, or we haven't considered thermal energy transfer to other objects in the room. For example, in the room we have furniture, some energy will be transferred to the furniture, some energy will be transferred to the curtain, some energy will be transferred to the walls. So energy supplied by the heater has been transferred to other objects in the room as well. Part of the energy is used to increase the temperature of the air. So some energy is used by furniture to raise its temperature, some energy is used by walls, some energy supplied has been used by curtains and other objects in the room as well. And some energy has been lost through windows, through doors. We haven't considered those things. So that's the reason this is the minimum time. But practically time will be longer than time calculated in part A2. So these things we need to understand. So let me show you the answer, or you can write down your answer. In your answer you can mention these points. You can say thermal energy is transferred to furniture and other objects in the room, and thermal energy is transferred to windows and doors from the room. So part of energy is used to increase the temperature of the air in the room. So very important point. So you need to understand this one. When we heat up air, energy is not only used to increase the temperature of the air in the room, energy is used to increase temperature of the furniture. Energy is also used to increase temperature of the curtains, also used to increase temperature of the walls, temperature of the ceiling, and also some thermal energy has been lost through windows and doors. So these things we need to understand. Very nice. Not just to memorize and write the answer, try to imagine, visualize these things. If we go to this part B, for part B, it is given to us figure 5.2 shows a cross section of a double glazed window in the room. State the main methods of thermal energy transfer from the room to outside which are reduced by this type of window. So in this case, simply if you look at this window has glass, and glass is solid. So glass is solid, so thermal energy this is solid, so thermal energy will be transferred by conduction. So we can say by conduction. So thermal energy will be transferred by conduction. And it is given to us, we have air inside this one. So this one is air. And air is fluid. In fluids, thermal energy mainly is transferred by convection. So we can write down convection. So these points you need to understand. So here we need to write down simply conduction and convection. Conduction and convection. So these points we have to write down for the answer of this question. Conduction and convection. Question 6 says two types of seismic waves are P waves and S waves. For part A, state the types of wave that P waves and S waves can be modeled as. P waves and S waves. P waves mean primary waves. Primary waves cause buildings to vibrate like this, means like this. And these waves are longitudinal waves, so we call them longitudinal waves. And these are the most dangerous one, so we call them longitudinal waves. Primary waves are most dangerous because buildings are not good under tensile forces, mean under tension, but buildings are good under compressive forces. And S waves, they cause building to vibrate up and down, so we call them transverse waves. So those waves can be modeled as transverse waves. So these 2 points you have to write down for part A. For part B, it is given to us the velocity of a P wave in the Earth's solid crust is 7.2 kilometers per second and frequency is this one. We need to calculate wavelength of this P wave. So wavelength, simply we can calculate, this will be equal to V divided by frequency. Velocity is given to us, that is 7.2 kilometers per second, so we have to multiply by 1000 divided by frequency, that is 4.5. If we solve this one up to 2SF, we will get 1600 meters. So this is the wavelength. So simply we have to write down here 1600 meters. Question 7 says figure 7.1 shows a container of oil. A ray of light shines on the surface of the oil. The refractive index of the oil is 1.47. On figure 7.1, draw the normal at the point where the ray enters the oil. So simply we need to draw one line here that has to be perpendicular to the surface like this. Or simply you can draw a beautiful line like this. This one has to be perpendicular to the oil surface. This angle has to be 90 degrees. For part B, it is given to us the angle X is 56, means this angle is given to us, this is equal to 56 degrees. So this one is 56, so this angle has to be 34 because the total angle is 90 degrees. So this angle has to be 34. We need to calculate angle of refraction. Angle of refraction mean in the oil. So if no change in medium, ray has to go like this, but there is a change in medium, so it will bend towards normal. So let me draw again. So it will bend towards normal like this. So we need to calculate angle of refraction. So simply we have to use Snell's law. We can say N1, mean this is over medium 1 and this one is over second medium. So ray of light will go like this. So we have N1 sine of theta 1. This one has to be equal to N2 sine of theta 2. So this is medium 1, this is medium 2. N1 for medium 1 is 1. This is air. So here we have sine of 34 degrees. N2 is given to us. This is equal to 1.47. So we have to find out sine of theta 2. So if we simplify this one, we can write down sine of theta 2. This will be equal to sine of 34 degrees divided by 1.47. So sine of theta 2 has to be smaller than sine of 34. So if we solve this one, theta 2 from here, we will get sine inverse of sine of 34 divided by 1.47. If we solve, we will get 22 degrees. So this is our final answer, 22 degrees. Simply you have to use Snell's law, and you have to be careful. Angle of incidence is this one. Angle with the normal means the angle between ray and normal. So we have to take 34 instead of 56. Part C says state the approximate speed of light in air. Speed of light in different media is different. So question is asking you speed of light in air or speed of light in vacuum. Approximately these two speeds are the same, but the speed of light in vacuum is the fastest, but speed of light in air is a bit slower. But at this level we can assume speed of light is the same in air as in vacuum. So we can simply say this is equal to 3.0 times 10 to 8 meters per second. For part D, we need to calculate speed of light in the oil, and we need to give answer up to 3 significant figures. So for this question we have refractive index of oil, that is equal to 1.47. Now we need to understand refractive index of air times speed of light in air. This one has to be equal to refractive index of oil times speed of light in oil. For this question we need to calculate speed of light in oil. So this will be simply equal to refractive index of air. So we can say an air speed of light in air divided by refractive index of oil. So refractive index of air is 1, speed of light in air is 3.0 times 10 to 8, and refractive index of oil, this is equal to 1.47. So simply we need to divide. If you divide by 1.47, you will get 2.04 times 10 to 8 meters per second. Our answer has to be up to 3 SF, so this has 3 SF. So simply you have to write down 2.04 times 10 to 8 meters per second. So you also need to write down the unit. So this is how you can answer. This is a beautiful way. So try to understand this one. So it's important to understand this. You can say refractive index in medium 1 times speed of light in medium 1. This one has to be equal to refractive index of the second medium times speed in the second medium. You can also see from here, if the refractive index is greater, it means speed in that medium will be slower, and vice versa. That's all for today's video. I hope this video was helpful. If this video was helpful, please like and subscribe, and also leave some comments in comments section. And also if you have any questions, please leave your questions in comments and I will try to answer as soon as possible. If you need more help from me, and also you want to support the work I'm doing on YouTube, please join Patreon. On Patreon, you can be connected with me more directly. You will be able to ask me more questions, and also on Patreon, I'm arranging weekly sessions. You can also join those weekly sessions for IGCSE physics, for AS physics, for A2 physics, and also for different physics competitions like BPHO, like Physics Bowl from US. And also if you wanna apply for Oxford University or Cambridge University, I also train student for Oxbridge, mean for Oxford and Cambridge University admission test. And also you can join sessions, training sessions for PAT and ENGA, and also for NSAA for Oxbridge admission test on Patreon. Looking forward to see you on Patreon. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from June 2023, Paper 4, Variant 2. In today's lesson, we will talk about electromagnetism, magnetic field, electric field, DC circuits, then also we will discuss astronomy and cosmology. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 8 part A1 says, what is meant by a magnetic field? magnetic field simply is a region around a magnet where another magnet will experience a force, or we can say is a region around a magnet where a magnetic pole will experience magnetic force. That we also need to understand, there is no magnetic monopole in nature. Means magnetic monopoles do not exist in nature. We don't have single north pole, we don't have single magnetic south pole. So always when we have a magnet has two poles, one is north pole and one is south pole. So for this question, simply magnetic field means that the region around the magnet. So this region is the magnetic field. So simply we can say for the answer of this question, region in which a magnetic pole experience a force, or we can say an other magnet will experience a force. For the second part, we need to define direction of a magnetic field. Define direction of a magnetic field. So you can see in this case we have these lines. These lines are representing magnetic field lines. The question is that how we draw these arrows, for example this arrow to the left, and how we have drawn this arrow also to the left. So imagine that if we place a north pole here, so simply imagine if we have north pole, single north pole. What is direction of force on this one? Direction of magnetic force on this one. This will be to the south pole, mean in direction of this arrow. Now we can also imagine if we place north pole here, so this is the north pole. Let me draw a little bit bigger one. So imagine that we place over north pole here now. So this is north pole only. So the force on this one will be to the left. So that's the reason this arrow is to the left. And if we place north pole here, for example, at this point, if we place the north pole, the force on this one will be to the right, and so on. So this is how we draw magnetic field lines, and direction of magnetic field lines tells us direction of force on north pole. So these points you need to understand. I hope this makes sense to you. So for the answer of this question, simply you can say in direction of the force on the north pole. So if we place north pole here, for example, at this point, direction of force on the north pole will be this way. Means north pole will experience force to the right. So this is how we need to answer these questions. And electric field. So if we try to understand a little bit about electric field, imagine that we have, this is a positive point charge. So how we draw the electric field? So important point to compare these two things together. So these are the electric field lines. So the arrow on this one has to be to the right, arrow we have to draw here to the left, and arrow here we have to draw in upward direction, here we have to draw in downward direction. Now the question is that why we have drawn these arrows in this direction? Because in this case we are assuming if there is a positive point charge here, direction of force on this one will be to the right, and if we place positive point charge here, direction of force on this one will be to the left, and on this one will be in upward direction, on this one will be in downward direction. So this is how we decide direction of electric field, and this is how we decide direction of magnetic field. Part B says figure 8.1 shows a negatively charged metal sphere. On figure 8.1, draw 4 lines to show the electric field and its direction. So first of all, we need to understand we have metal sphere. So the electric field inside any metal sphere should be equal to 0. So simply we can write on here electric field inside has to be equal to 0. So the electric field lines now we need to draw from the surface. So very important point. Now you can imagine simply we have negatively charged particle. So this particle has negative charge. So how we can draw the electric field lines? Electric field lines. So direction is important. So we can imagine unit positive charge as we discussed before. Imagine that we place one unit positive charge here. So the force between these two will be attractive, and this positive charge will experience force to the left. We can also imagine if we place unit positive charge here, this will be attracted by this negative charged. So it will be force on this one will be to the right. if we place unit positive charge here, this will be attractive. So the force on unit positive charge, this will be in downward direction. And if we place unit positive charge here, force on this unit positive charge will be in upward direction. Means force is towards the charge particle, negatively charged particle. So if we have understanding of these things, we can draw the 4 lines here. So we can draw one line here, we can draw one line here. They have to be equally distributed, and we can draw one line here, we can draw one line here, and direction has to be towards the sphere, to the sphere. So you can draw these lines, they have to touch the sphere. So this is how you can draw electric field lines for negatively charged metal sphere. Part C says figure 8.2 shows a circuit. The 3 cells are identical and have 0 resistance. The resistors R1, R2 and R3 also identical. The reading on the voltmeter is 6.0 volts. When the diode is conducting, it has 0 resistance and 0 PD across it. Determine the EMF of one cell. So we have EMF of these 3 cells, that is equal to 6.0 volts. So we have one cell here, we have 2 cells, this is the second one and this one is third one. So simply we can say in this case total EMF, this is equal to 6.0 volts. So we can say N times EMF of single cell, this is equal to 6.0 volts. So from here we can find out EMF of single cell. This one has to be equal to 6.0 volts divided by 3. So we will get this is 2.0 volts. So the final answer we can write on 2.0 volts. Second part says determine the ratio of PD across R2 to the PD across R3. So it simply means that we need to find the ratio between V2 and V3. V2 is the PD across R2, so we can say this one is V2, the PD across this second resistor, and here we can write down V3, so this is the PD across R3. So first of all we need to understand for this circuit how current will flow. Current, let's say this current is I0, and current here, let's say this current is I1, and we can say this current, let's say this is I2, and current here we can say this is I3. So first thing you need to understand, I0 and I3, they have to be the same. I0 and I3, they have to be the same because current entering a battery and leaving the battery has to be the same. So this current I3 is equal to I0. Now we need to find out what is I1 and I2. I1 and I2, they have to be the same because these resistors, they have the same resistance, and the PD across this resistor and this resistor. So let me write down here, let's say this PD is V1, and PD across R1 and R2 also has to be the same. So we can say V1 has to be equal to V2. So current we can write down I0, this one has to be equal to I1 plus it has to be equal to I2. Means current at this junction, it will split into 2 parts and it will split equally into 2 parts because PD is the same, current is the same. So we can say I1 has to be equal to I0 by 2 and I2 also has to be equal to I0 by 2. So the sum of these two is equal to I0. Now we can simply write down here V2, this has to be equal to I2 times R divided by resistance is the same. If you want to write down R2, you can also write down, and this will be divided by I3 times R3. I2 is equal to I0 by 2 times R, and this is divided by I0 times R. So simply in this case we can cancel I0 with I0, we can cancel this R with this R, so we left with 1 by 2. So it means the ratio between V2 and V3, this ratio is simply equal to 1:2. So this is our final answer. This is what you need to write down. Third part says all the cells are reversed. For part 1, we need to state and explain the change in current in R1. All the cells are reversed. It simply means that negative terminal becomes positive and positive terminal becomes negative. So we can draw these blue lines to represent positive terminal. So in this case, current will flow like this. Now at this junction, no current will flow this way, so we can say I in this branch has to be equal to 0 because this diode is connected in reverse bias now. So we can say this is connected in reverse biased, so current will flow like this. So this is important one. You need to understand how current will flow in this circuit. So current will flow like this. So simply we can say current IR1, this will be equal to 0. Why? Because diode is connected in reverse bias. So we can say diode is now connected in reverse biased. So this is the point you need to understand. Now let me show you the answer, or you can write down your answer. So this is how you can write down your answer. If you write down these 2 points like this, you will also get 2 marks. For the second part, we need to determine the new value of the ratio of the PD across R2 to PD across R3. So in this case, you can see, let's say this current is I naught. So the same current flow through this resistor and also through this resistor. They also have the same resistance. So it simply means that ratio between VR2 and ratio between VR3, this ratio has to be the same, means 1:1. So that's all what you need to write on. I hope this one is clear to you. That's all for today's lesson. I hope you have better understanding of electricity now, and remaining 2 questions I'll be uploading as soon as possible. See you in next video. And if you have any questions, please leave your questions in comments, and I will also try to answer your questions as soon as possible. Bye for now.
Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from June 2023, paper 4, variant 2. In today's lesson, we will talk about radioactivity, space, and universe. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together. Let's improve together. Question 9, part A says table 9.1 shows some properties and values for alpha particles, beta particles, and gamma radiation. Complete table 9.1. In order to answer this question, first of all, we need to understand properties of alpha particle, beta particle, and gamma radiation. Let's try to understand properties of these particles and radiations. We have alpha particle, and alpha particle is simply a helium nucleus. So very important point, you need to understand what is alpha particle. Alpha particle is just simply a helium nucleus. So it has no electrons. And alpha particle, it consists of 2 protons because atomic number is equal to 2. It means it has 2 protons, and mass number is equal to 4. So 4 minus 2 is equal to number of neutrons. So it has 2 neutrons. And charge on alpha particle is equal to plus 2e. This is equal to the charge on 2 protons. And elementary charge 1e, this is equal to 1.6 times 10 to minus 19 coulombs. Now let's try to understand beta particle. Beta particle simply means that we are talking about electron, fast moving electron. So beta particle is simply fast moving electron. So this point is important. You need to understand what is beta particle. So as it is fast moving electron, it means no protons and no neutrons. And charge on this one, charge on electron is minus e. It means this is minus 1.6 times 10 to 19 minus 19 coulomb, means negative charge on beta particle. And gamma particle, it has no charge and it has no proton, no electron. So proton, number of protons equal to 0. It has no proton and it has no neutron. And the charge on this one also is equal to 0. We can say Q, this is equal to 0. How we can stop this one? Because we have to write down here how we can stop gamma particle, gamma radiation, in fact not particle. Gamma radiation can be stopped by very thick wall, we can say very thick wall of concrete, or we can say lead. So this is how we can stop gamma radiation. Now let's try to fill this table, complete this table now. Alpha particle number of neutrons, it consists of 2 neutrons as we have written here. Beta particle number of protons, 0, so we have written here. So it has 0 number of protons. Charge on beta particle, charge is equal to this. So simply we can write them here. So this is minus 1.6 times 10 to minus 19 coulombs. Gamma radiation number of neutrons, 0. Charge, 0. So that's all what we need to do to answer part A.
Part B says state how beta decay changes the nucleus of an atom. So first of all, let's try to understand beta minus decay. Beta minus decay. Let's say we have nucleus X. It decays into nucleus Y by emitting beta minus particle. If beta minus particle, it means there is also electron anti-neutrino. But for this question, simply we need to understand the change in the nucleus of an atom. This nucleus, imagine that it has atomic number Z and it has mass number A. So when beta particle is emitted, atomic number of this one will increase by 1, but the mass number will not change. It simply means that one neutron changes into proton in this decay. Neutron changes into proton. It simply means that proton number increases. It has one more proton and it has one less neutron. So one less neutron. Neutron number decreases. So we can say one more proton in nucleus Y. So we can say one more proton and one less neutron. So these points you have to write down, and this is how you can answer this question. So simply you have to understand how the proton number is changing and how the mass number remains constant. So if mass number remains constant, proton number increased by 1, it means one proton changes into one neutron. So this nucleus has one extra proton and one less neutron. Part C says a radiation detector used in a laboratory detects a background count rate of 30 counts per minute. A radioactive source is placed in front of the radiation detector. The initial reading on the detector is 550 counts per minute and half-life of the source is 25 minutes. Calculate the expected reading on the detector after 75 minutes. So first of all, we can write down, for this question we have value of background count rate. So we can write down background count rate. Very important point, step by step you need to understand. It's a beautiful question about half-life. We can also say this is a typical type of question, or we can say it's a difficult question on half-life. We have background count rate that is equal to 30 counts per minute, and this count rate is always present. So we have 30 counts per minute. We also have initial reading. So this is initial reading on detector. So we can say initial reading on detector. Initial reading on detector is equal to 550 counts per minute. From these two informations we can find out initial count rate due to source only. So we can say initial count rate due to source only. We have total count rate that is 550. So if we minus background minus 30, so in this case we will get 520 counts per minute. So this is due to the source. And we have 75 minutes. It is given to us total time 75 minutes, and 75 is equal to 3 times 25 minutes. And 25 minutes is one half-life. So it means we have 3 half-lives. So we can write down number of half-lives. Number of half-lives in this case will be equal to 3 half-lives. So now we can write down final count rate due to source only. Final count rate due to source after 3 half-lives, final count rate due to source only, or you can say after 3 half-lives. And this one has to be equal to 520 multiplied by 1 by 2, 3 times 1 by 2 and 1 by 2. So it simply means that we have to divide this one by 8, and if we solve this one we will get 65 counts per minute. 65 counts per minute. So this is due to the source only. But question is asking us expected reading on the detector. Reading on detector. So we can write down reading on detector. Actually this is expected. Expected can be a little bit plus minus because decay is random. So that's the reason they have written expected reading. I'm writing reading on detector. Reading on detector. So the reading on detector has to be equal to final count rate. We have 65 plus background. Background is 30 counts per minute. So final reading will be 95 counts per minute. A beautiful question. Try to understand this one step by step. So we have 95 counts per minute. So the final answer we need to write on here 95. So this is how you need to answer. It's a beautiful question. Try to master this. Part D says state 2 safety precautions taken when moving, using or storing radioactive sources in a laboratory. First of all, moving. So when we want to move radioactive sources, we should wear gloves. We can write on the first one, wear gloves. Wear gloves. So 1 point second, you can also say use tongs. Don't touch radioactive sources directly. When using radioactive sources, keep distance from sources. We can say keep distance from sources. Keep distance. The second point we can say limit time of exposure. Limit time of exposure means don't stand in radioactive source room for a long time, or don't do radioactive experiments for a long time. So limit time of exposure. Storing, and we should store actually radioactive sources in lead boxes, or we can say in lead containers. For this question you need to write only 2 of them, so you can write on 2 of them for the answer of this question. So we have talked about 5, so you can write on any 2 of them. Question 10 part A says state the equation that defines the average orbital speed of a planet. State the meaning of any symbols you use. Orbital speed, and orbital speed simply equal to the distance traveled by planet in one rotation divided by time taken divided by time. And distance traveled by a planet in one rotation, or we can say in one cycle, that is equal to circumference of the circle divided by the time period, time taken to complete one cycle. We need to write down the meaning of this symbol. What is R? This is average. This one is average radius of the orbit. Average radius of the orbit. And T is the time period. We can say this is orbital time period, or we can say this is orbital period. So this is how we can answer question 10 part A. Part B says suggest why countries that are a significant distance from the equator experience significant temperature variation throughout the year. For that purpose we need to understand that rotation axis of our planet is tilted. As you can see here, rotation axis of our planet, this is tilted. As rotation axis of the planet is tilted, so the sun rays from the sun, they reach countries above equator and below equator at different angles throughout the year. So as angle change, the amount of light coming from the sun, it's spread over different area. Let's try to understand what exactly it means. You can do this experiment by yourself. First of all, you have the light source. It is at an angle of 90 degree to the surface like this. Actually, this is happening at the equator. You can also see here. So light is concentrated in this smaller part. But as angle change, you can see the light spread over larger area. So this part will be colder. We can say this will be cold as compared with this one. So this will be hot. But at equator, throughout the year, angle is the same. So the change in temperature is very small. So you can see with this demonstration as well. So light will concentrate at this area. If we change the angle of the light, you can do it by yourself. Now this angle is 45 degrees. In this case, you can see the same light, it's spread over large area. So in this case, intensity of the light will go down, so the temperature will decrease. So as this angle keep on changing, the spreading of the light over area will be different. It will spread small area, it will spread on large area. Based on that one, there will be variations in temperature. So these are the points we need to understand. But if you look at equator means this part, this always remain at almost the same angle. So you can see this almost remain at the same angle. You can see here almost this part always remain at the same angle almost, and this part also on other side it also remain at the same angle, mean opposite side of this one. So the temperature at equator, like Singapore, there is no big variation in temperature. So temperature almost remain same. So it is just simply due to angle, and that is due to rotation axis of the planet that is tilted. You can also understand from here. So let's say this is our planet. So here is equator, and here is North Pole, and here is South Pole. So it is tilted like this. So here rays will spread over larger area, so this will be colder, and this one will be hotter because this will be closer, and so on. So these points you need to understand. I hope this is clear. So now let me show you how you can write down your answer. For the answer of this question, you can write down these points. You can say rays from sun strike the countries at different angles throughout the year, and this is due to tilt of our planet about its rotation axis. So the rotation axis is tilted from the vertical. Part C says fill in the gaps in the paragraph about a star much more massive than the sun. Means we are talking about more massive star. If you look at this diagram, you can see we have sun-like stars, they follow this cycle, and we have more massive stars, they follow this cycle. In the question, it is given to us the stage that follows a stable state in the life cycle of the star is the stable state. More massive star, when they reach this stage is the stable state in the life of more massive star. So this one is the stable stage. So simply you need to write down red supergiant. So you can say this is red supergiant stage. Then it is given to us it explodes as a supernova to form. So it explodes as a supernova and it forms nebula. So the next stage is nebula, after explosion, nebula. And after nebula, this leaves behind a neutron star or black hole. It depends on the mass of nebula. So we can write on here. So we have neutron star, or there will be black hole. It depends on the remaining mass. So this is black hole. Part D says a galaxy is moving away from the Earth with a speed of 33,000 kilometers per second. The value of the Hubble constant is 2.2 times 10 to minus 18 per second. Calculate the distance from the galaxy to the Earth. Give your answer in light years. So answer has to be in light years. So this is very important point. And we need to understand 1 light year. So first of all, let's try to understand 1 light year. 1 light year is equal to 9.5 times 10 to 15 meters. So this is important point you need to understand. So simply we need to use Hubble's law. According to Hubble's law, V is equal to h naught times t. So we need to find out distance in this case. So for the distance, simply we can write down this is V divided by h naught. The value of V is given to us, that is 33,000 kilometers, so we can convert this one into meters, divided by value of h naught, that is 2.2 times 10 to minus 18 per second. So if we solve this one, our answer will be in meters, but we need our answer in light years, so we will divide this one by 9.5 times 10 to 15. Now if we solve this one, we will get 1.6 times 10 to 9 light years. So this is our final answer, and this is how we can approach this type of problems. So the main point is we need to understand 1 light year is equal to this, the relationship between light year and meters. And that's all for today's lesson. I hope this video was helpful. If you have any questions, please leave questions in comments and I will try to answer as soon as possible. And also, if this video was helpful, please like and subscribe because your encouragement is very important. See you in next video.